Welcome to my online class. Welcome to Mr. Bam's online class today. How are you doing? Hope you are nice and good. So, today we are looking into physics. You understand? And we are looking into this UTME question. That's 2018 question on UTME. So, the question says water of mass 120 gram at 50 degrees Celsius is added to 200 gram of water at 0 degrees Celsius, and the mixture is well stirred. Calculate the temperature of the mixture. So let's see what we do. How do we handle this kind of question? So first of all, this topic comes from eat. Eat. It's come from eat. You understand me now? So and if you remember, I made a video on eat for you before. You understand me now? So this topic is on specific heat capacity. Specific heat capacity. You understand? Is on specific heat capacity. Do you understand me now? So on specific capacity, there are two methods that you can use to determine specific heat capacity. Do you understand me now? We have two methods. We have the first one is method of mixture. Method of mixture. Method of mixture. You understand? And second one is electrical method. Electrical method. So this question is on method of mixture. Why? Mixture. Somebody needs to bathe at water at temperature that is warm, a warm temperature water. So, but there is no warm water yet. So the person now say, okay, what will I do? The person look at uh, hot water at relatively higher temperature. That's hot water. Person take hot water with a cold water. Person mix together to get a warm water. Should you get it? That's just the principle behind this. The hot water is being mixed together with a cold water relatively to get a warm, water. So the person now took water of mass 120 gram. You know what I mean now? With water of mass 200 gram. It's happening a lot. Maybe at home you need to bathe with water. You the first tap, you have two tap. The hot tap, the hot one, the hot tap, the hot tap, you understand me now? And the cold one. And the cold one, you understand me now? So let's say we have two different water. We have water at 50 degrees Celsius and we have water at 0 degrees Celsius. So between them, one is hotter. This is the hot one, and this is the cold one. You understand me now? So that hot one, look at the mass of that water, 120 gram. That is the level by which the water, reaches the bucket or container is 120 gram. You understand me now? So we have this. This is the hot water at 120 gram. That's the mass. You can see we have the mass is 120 gram for water as 50. So this water, the temperature is 50 degrees Celsius. That's the temperature, and the mass, the amount is 120 gram. So the person now mix this hot water with a cold water. Cold water, that's the one at 0 degrees Celsius. You can see. So the temperature here is 0 degrees Celsius. You understand me now? But the mass of this one is 200 gram. 200 gram. Which means that 200 gram is more. Let's say the person uses the same kind of container. So 200 gram will be more, will be much than that 120 gram. So 200 gram will be at higher level compared to 120 gram. You understand me now? So that's the mass, the quantity, the amount. You understand me now? So this water at 0 degrees Celsius has more amount, 200 gram. While the one at 50 Celsius, the one that is somehow, water, you understand me now, has a lesser mass. It's not as much as the colder one. You understand me now? They now say, okay, the person now mix the two together. You can see mixture. So that's why we call it method of mixture in specific heat capacity. You understand me now? So that's what is happening. The person mix together and then you get a warm water. You understand now? You remember those period when we are young, maybe the time of cold, when our mom wants to bathe us with some warm water. Our mom will take hot water, they mix together with the cold water to give them, the warm water, and then they start to bathe us. So the same thing is happening here. So water of mass 120 gram. This is 120 gram, the level of that water, where the amount of water at 50 degrees, that's the temperature, is alter. You understand me now? It's now added together to 200 gram of water at zero. This one is at zero. That means colder. You understand me now? 50 is hotter, zero is colder. That's the temperature. But the mass is 200 grams. It has more, amount. And also we should, and the mixture is well stirred. They stir the mixture together and then stir together. And also calculate the what? Temperature of the mixture. So what will now be the temperature of that mixture? Of course, the temperature will be in between this, because we have the hotter one, colder one. So the warm one will be around maybe between 0 to 50. You understand me now? So it can be 60. You understand me now? So of course the temperature is around this because it's warm. So let's see, how do we do it? Very easy and simple. Very easy and what? And simple. So let's see. So you remember law of conservation of energy. Law of conservation of energy states that what? Energy can neither be created nor destroyed, but can change from what? From one form to another. So this is what you do. You say, the hot water has been mixed with the cold water to give a warm water. So we have the hot. This is hot water. You understand me now? This is the cold water. Do you understand? So the two of them are mixed together. They come together to give a warm water. Do you understand what I mean now? So to give a warm water. So what happens here? Now listen. The temperature of the hot water is always theta 1. 1 is always for the hot water. Notice the hot substance, theta 1. While the cold one, the temperature is what? Theta 2. You understand me now? So theta is symbol for temperature. Theta 1, theta 2. So from this question, the hot water is 50. That means that one is 50 here. 50. You understand me now? That's 50. You understand me now? While the cold one is what? 0. That's theta 2. That's 0 degree Celsius. So to now give a warm water. So we are asked to look for the temperature of that warm water. You understand me now? So now, the mass. Now, let me explain to you. Before you answer this kind of question, you have to say, it's lost. It's lost by hot water. It's lost by hot water. It's lost. You understand? It's lost by hot water. You understand me now? Is equal to what? To its gained. It's equal to its gained by cold water. So you understand me now? It's gained by what? By cold water. Why? Because you should know the hot one and cold one, they come together to become warm water. Warm water. Which means that the hot water goes all the way to become warm. The cold one also goes all the way to become warm. So both of them come all the way to become warm water. So that warm water, the temperature will now be theta 3. Because theta 1 for the hot, theta 2 for the cold, they come together and become theta 3. So its loss by hot water is equal to its gain by, because the hot water has lost heat to warm water. It has become relatively colder from hot to warm. So it has come down. It has lost some heat. While the cold water has gained from cold to warm. It has become relatively warm. The temperature has become higher from cold to warm. So the hot water has lost heat, while cold water has gained that heat. So no heat is lost. The heat lost by this hot has quickly gained by cold water. So and now, what's the formula for heat? Don't forget that heat has the formula MC changing theta. For my last class, heat energy has formula of this. So heat lost by hot, MC theta, for the hot, let me say bracket H for hot water is equal to the same heat again, the same formula for heat again, MC theta. You understand me now? But for what? For cold. Let me use C for cold water. For cold water, that's C. You understand me now? So MC change theta for hot water equals to what? MC change theta for what? For cold water. Sure, you understand me now? So note it. So this is the formula we are going to use. So let me break it down now. So now, this is the mass of hot. So you take the mass of hot water, that is the quantity that you put the hot water, that's 120 gram. the amount, that's mass of water, that's mH, then times what? Times specific capacity of hot water. You understand me now? But there is something you have to note here. The specific capacity of hot water is same thing as the specific heat capacity of cold water. The symbol for specific capacity is C. We have done it before. Specific heat capacity is C. So what's going to happen? Then C for hot water, we cancel C for cold water. Since they are both water and water, either hot or cold, they have the same specific heat capacity. So you cancel the C here. So the remaining one is what to write out. You understand me now? So let me write it out now. Let me write the formula out. Let me write it out. So we are going to have what? mH, that's mass of hot water, mH, times what? Times mH times temperature change. So what's going to be the temperature change for hot water? You know, we said the hot water has become warm. Hot water becomes warm, which means from theta 1, hot water, the temperature of hot water is theta 1. It has come down to warm, that's theta 3. Hot 1, we are talking about hot now. Theta 1 becomes warm. So the temperature change will now be theta 1 minus, that's the temperature change, we subtract it. You understand me now? So that's the times what? Theta 1 minus what? Theta 1 minus what? Minus theta 3. Should you get me now? That is the heat for hot water. Now equals to what? Equals to the same mass of cold water, MC, mass of cold water. So this time around, our temperature change will now be, let's see, cold water. How does cold water becomes warm also? We have done for hot water becomes warm. Cold water, you know the cold water has temperature theta 2. So it also becomes theta 3 also. So theta 2 from cold to theta 3. So the temperature change will now be theta 3 minus theta 2. Because the warm water has more temperature than the cold one. So that's theta 3. You understand me now? The warm one minus cold minus theta 2. Show this now. So this is the formula you are going to use for this kind of question. Mass of hot water into brackets, theta 1, that's temperature of hot water minus temperature of the warm water, the final temperature of the mixture, that's theta 3, equals to mass of cold times theta 3, that's the final temperature of the mixture, minus temperature of the cold water, theta 2. So always apply this formula when you are given such kind of question. So please note it. Do you understand? Note it. So we are going to use this formula. Mass mH, theta 1 minus theta 3 equals to MC, theta 3 minus theta 2. So from the question, let's see. The mass of hot water is 120, that's mH. 120 gram hot water, that's 120 times theta 1 is the temperature of the hot water, that's of 50 degrees. For us, so we have 50 minus, so we are looking for theta 3 in our question. So put theta 3 there, we are looking for it, theta 3. That's the final temperature of the mixture, theta 3, the temperature of the warm water. So equals to, what's the mass of cold water? 200 gram, because it is 0, so that is colder, so that's 200. So we have 200 into brackets. We are looking for theta 3 also, the same thing. So put theta 3 minus, our theta 3 is what? Temperature of the cold, that's 0 minus 0. So we are going to work on this square formula, and then we collect items and get our theta 3. So let's see. Open the bracket. You can even do it this way. 120 is there, 200 is there, so you can cancel 0 here. Then something can go in 12 and 20. 4 can go. 4 here, 3. You can see 4 here, 5. So just say 3, open the bracket. 3 times 50 is 150 minus 3 times theta 3 is what? 3 theta 3 equals to 5 times this is what? 5 theta 3 minus 5 times 0 is 0. So just leave that one. So we just collect like terms, you see. So 150 equals to 5 theta 3. So when this minus goes here, that's plus 3 theta 3. You understand what I mean now? So 150 equals to what? 5 plus 3 is 8. That's 8 theta 3. So when we divide both sides, theta 3 equals to what? Equals to 150 over 8. 150 over 8. And our answer is what? Our answer is what? That is 25. Is it 25? Let me check very well. 8 and 15 is what? Is 1. So this is because that's 75 over 4. Over 4. You understand what I mean now? So over 4. Then from there we have what? 4 is 25, that's what? That is 18. 18 point what? 0.75. So answer is 18.75 degree Celsius. So this is the temperature of the mixture. So the option is not there, which means sometimes option may not be in the series. So this is the correct answer. So the final temperature of the mixture is 18.7. You can see that the temperature is 18. In between the cold temperature and hot one is around 18.75 degree Celsius. So that's it. So if you have any question, you can put it in the comment section. Sure, you understand me now. So once again, thank you so much. Welcome to Mr. Bounce online class. Hope you have learned one or two things from this question. So thank you so much. Please don't forget to like, to love, to comment, and then to share my video. Thank you so much. Remain blessed.